Rutherford's nuclear model for the atom states that atoms consist of electrons orbiting around a nucleus. So Rutherford's model shows orbiting electrons around a central, positive, massive nucleus. But where did the idea of orbiting electrons come from? Well, in 1913, Niels Bohr refined this model by theorising the electrons could only orbit the nucleus at set distances. So there are set orbits at particular distances, and today we refer to these orbits as shells. But what determines the orbit an electron is in? Well, these orbits correspond to the energy carried by electrons. So in the lowest orbit are the electrons with the lowest possible energy. And the higher orbits are for electrons with higher energy. So the higher the energy, the higher the orbit. So how did Bohr think that electrons could change orbit? Electrons can change orbits by gaining or losing energy as electromagnetic radiation. So an electron moves to a higher orbit if it absorbs or gains energy from electromagnetic radiation. But the electron needs to absorb the exact amount of energy required to move up to a higher level. An electron can also release electromagnetic radiation. If it does this, it can then move to a lower energy level. So what evidence was there to support this theory? Well, the theoretical calculations Bohr used to determine these energies agreed with experimental observations of radiation from hydrogen. When electromagnetic radiation is emitted, we can measure its wavelength, which determines its energy. But you don't need to know the details of how to do this at GCSE. But known evidence supports Bohr's theory, as the properties match calculations, and only certain wavelengths of radiation were observed from hydrogen. But did Bohr's calculations apply to all atoms? Well, the calculations for larger atoms were incorrect. Bohr's model failed for larger atoms, as the method used to calculate energy levels in hydrogen no longer worked, and the values were different to the predicted value. Parts of Bohr's model still worked, as there are still fixed energy levels, and only certain wavelengths were emitted. You don't need to know how electrons are actually arranged for these larger atoms at GCSE, and you can assume Bohr's model still works for them.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!